easier than all this integration things, which are the uniformly accelerated motion here. Okay. So what they did was they showed you the generic, solution of how to relate velocity, position, acceleration, and time together. And they're like, but wait, a lot of times acceleration is constant. So can we come up with some equations that we don't have to derive every time in order to use them for constant acceleration, which is what they did here. And you probably will remember the equations of if A is a constant, and that means that it is a number. Okay, so 9.81, free-falling things, that has constant acceleration. Or, 2 meters per second. But like 2t would be a non-constant acceleration. So again, you can only use it if A is equal to a number, and then you end up with these three equations. Do you guys remember those? We also used them for projectile motion a little bit 3 semesters ago, at least. Okay. So these are much simpler problems than the integration one. You just figure out what you know, which equation you can use to solve for the unknown, and then use it. So I think we probably in our packet have, yes, I think we can get through this one last problem here. And I'll look back through this somewhere. I think it has to do with the logarithmic stuff there, but I'll fix that problem there before you do the homework. So a sprinter in a 10-meter, 100-meter race accelerates uniformly for the first 35 meters and then runs with a constant velocity. Constant velocity is also constant acceleration. What would the acceleration be for a constant velocity?
0.
Good, that would be 0. So this time for the first 35 meters is 5.4 seconds. So we want to find a bunch of these things, which includes acceleration during the first 35 meters, acceleration for the last 65 meters, which we actually just found, final velocity of the entire race, and then the time for the entire race. Okay, so we have 2 different sections of this race that we have to consider separately because their accelerations are different. Okay, so I just did a little visual of kind of what's going on here. So at the beginning of the race, your time, velocity, and position are all 0. When we get to 35 meters, the time is 5.4 seconds, but we don't know the velocity. Okay. So we need to find the velocity, and so since we know the time and the position, then those 3 equations here, we should be able to figure out whatever has read. What would we use here? Would this one work? Would that one work? That's one of them. So this one would work, wouldn't it? Right? Because we know the time, and we know the initial velocity.
Will the second one work as well?
I think so. Oh, we don't know the acceleration. Okay, so we know the velocity. We're trying to find the velocity here. We know the initial velocity. We know the time, but we don't know that. So I guess what I was trying to do here is v is equal to v naught plus A times T. So we don't know what that is, and we don't know what that is. So we can't solve for it. So we could use, yeah, and so even if we used this one up here, we still couldn't solve for velocity because we don't know what acceleration is. So what we have to do first is use the following equation for acceleration from your x. So we know the positions and the time and the time. Okay, so in that case, the acceleration is the only thing that we don't know. So I will just put that in. So we have 35 meters is equal to 0 plus 1/2 a times t squared, t being 5.4 seconds. And so then acceleration is equal to 2.4 meters per second squared. So now we can use that equation. V is equal to V naught plus A times T. So the velocity at the end of, and I'm just going to put a little subscript here. Velocity at the 35 meters is equal to that 12.96 meters per second. So then from 35 to 100 meters, we need to figure out the time. So we know during this that A is equal to 0. So we know that x is equal to 100 meters. And x naught is equal to 35 meters. The initial velocity is 12.96. And A is equal to 0. So we have a lot of information about position here. Okay, so kind of in light of that, we're probably going to be able to use this equation. With that last term being 0. So now we have that the time that it takes to go from 35 meters to 100 meters with 0 acceleration is 5.01 seconds. And then we just have to add the two times together. We get our final time. So how fast is it coming back? All these kinematic equations.
Not fast enough.
Not fast enough.
Yeah.
If it's any consolation, somebody heard from somebody else that this first part is the hardest. So if that makes you feel any better.
It only gets better.
So I know we're gonna do enough problems to have the equations memorized, but are they gonna be on the exam?
Yes, so you do not have to memorize any equations. And yes, none at all. You're gonna, I used to give formula sheets, but I think I'm gonna let you write your formula sheet out so that you can kind of put your specific notes on it that make sense to you. I've found what I do when I hand out a formula sheet is nobody looks at it until the test, and then they're kind of coming up, what does this subscript mean, or what does this mean? So I think I'm going to have you guys do your own formula sheet. We're doing that for 1510, 1520 also. Just a little change. I'll give you my formula sheets, and then you can work from them if you would like. Good. see you Friday. Seems like today should already be Friday.
Yep. I wish. It's only day 2.
Mr. Zach, do you need information from mine, which I did transfer?
Yeah, I will do a call right now.
Okay, do you need the information of like how much,
Yes,
what
yes.
5,000?
Yeah, so maybe your usernames.
Okay.
I may have me,
I got my username and my password and everything.
Okay,
and that's class reading.
yes.
Okay.
And everybody was in the spring class, correct?
Yeah.
Yeah, so go ahead and put your username. I don't need your password.
Okay.
And so, anybody else? Andrew, you said you also.
I was in, yeah, but it looked like your name was on McGraw-Hill login for Dynamics, but like I said, I couldn't access any homework.
Okay.
Yeah. It was
Maybe-
on there, then I clicked, and then Lynn's name came up, and all of the past homework of
Okay.
statics pass came up.
I'll call and see how we get you enrolled in the class. Somebody said it was only $20 more to do a year or something,
Yeah.
something along those
Yeah.
lines. That was smart to, yeah.
So this, well, she was like,
Yeah.